Coordinates. Satellite confirmation. A strike corridor threaded through 3 overlapping air defense zones. This wasn't a random attack on a fuel depot. This was surgical industrial sabotage, designed by engineers who understood exactly what happens when you crack a primary distillation column at peak operating pressure. Welcome to Ukraine Radar. I'm your host, where we analyze the battles that change wars. Today, we're breaking down one of the most technically sophisticated long-range drone strikes in this conflict. A mission that combined petroleum engineering knowledge with military precision to reach a target Russian defense planners considered untouchable. The Ryazan oil refinery sits roughly 180 kilometers southeast of Moscow. It processes about 17 million tons of crude oil annually. In the southern grouping's logistics chain, it sits at the top of the fuel supply pyramid. Aviation fuel, diesel, military-grade lubricants all flow south from this complex toward the front. Destroy the refinery's atmospheric distillation unit, and you don't just stop fuel production for a week. You collapse it for months, possibly for an entire operational season. That was the calculation. Not destroy, not burn. Crack the primary column at the Weld seam, where decades of thermal cycling had already stressed the metal, and let physics do the rest. The mission belonged to Ukraine's 14th UAV Regiment. To understand what made this strike different, you need to understand what a primary distillation column actually does, and why timing the attack to coincide with peak operating cycle was the difference between setting a fire and ending a refinery. A crude distillation unit is the first and most critical stage of oil refining. Raw crude enters at the base under pressure and heat. As it rises through the column, different hydrocarbon fractions separate at different boiling points. Naphtha at the top, kerosene in the middle, diesel and fuel oil lower down. The column runs continuously, under pressure, at temperatures ranging from 350 to over 400 degrees Celsius. At peak processing cycle, internal pressure hits its operational maximum. The steel walls are under constant thermal stress. Strike planners at Ukrainian military intelligence had obtained technical documentation on the Ryazan facility, not classified military documents, publicly available industrial safety filings, maintenance records, engineering permits. The kind of paperwork that sits in government databases and never gets scrubbed because nobody imagines it matters. It mattered. 3 engineers embedded with the targeting team had spent weeks working through the data. They identified a specific section of the primary column, a weld junction roughly 2/3 up the structure, where historical inspection records showed microfracturing consistent with long-term thermal fatigue. The column had been flagged for maintenance. The maintenance had been deferred, twice. Which weapon was deadlier in this mission? The long-range drone carrying the warhead, or the engineering intelligence that picked the exact impact point? Comment your answer below. The strike corridor was the second challenge. Ryazan sits inside concentric rings of Russian air defense. The innermost layer around Moscow is the densest missile defense concentration on the planet. 400 batteries, Pantsir S-1 systems, a -135 interceptor missiles. Further out, overlapping S-300 coverage creates a second ring. The gap between these rings, at certain altitudes and approach angles, narrows to corridors barely wide enough for a determined drone operator to thread. Ukrainian SIGINT analysts had been mapping those corridors for months. Intercepted Russian air defense radar emissions, cross-referenced with satellite imagery of battery positions, cross-referenced again with commercially available flight tracking data showing civilian aviation corridors, because commercial flights had to thread the same air defense gaps they were mapped around. The picture that emerged showed a viable approach from the southwest. Low altitude. Terrain masking along a river valley that dropped radar coverage for an 18-kilometer segment. 18 kilometers of invisibility, if you could stay in it. The 14th UAV Regiment launched a coordinated package. Not a single drone. Not even a small flight. 23 modified long-range UAVs departed from forward operating positions across a staggered timeline. Some from mobile platforms moving through Ukrainian-controlled territory, others from fixed sites further west. The stagger was intentional. Radar operators watching their scopes would see what looked like isolated contacts, not a coordinated swarm. Each contact, individually, might be dismissed as sensor noise or a small civilian drone. Together, they formed a carefully choreographed assault package. Stay with me. What happens in the next 18 minutes of this mission destroys one of Russia's most critical fuel infrastructure nodes and changes the calculus for every refinery within 300 kilometers of the front. 11 of the 23 drones were designated primary strike assets, carrying modified warheads optimized for penetrating the steel shell of an industrial column before detonation. The remaining 12 were electronic warfare, decoys, and defensive suppression platforms. Their job was simple: light up Russian air defense radars, force Pantsir batteries to engage, drain interceptor inventories, and create enough noise in the air picture that the 11 strike drones could thread the corridor undisturbed. It was a doctrine borrowed, ironically, from Cold War American strike planning. Suppress, penetrate, strike. Seed in miniature. Self-organizing suppression of enemy air defenses, executed by a regiment that didn't exist 5 years ago, with weapons that cost a fraction of the assets they were protecting against. The launch window opened in the early morning hours, chosen because Russian air defense crews are statistically least alert in the pre-dawn period. Shift changeovers create brief gaps in communication protocols, and thermal imaging conditions favor low-altitude flight when ground temperature matches ambient air. 3 minutes after the package crossed into Russian airspace, the first Pantsir battery engaged a decoy. The engagement was exactly what Ukrainian planners had designed for. The Pantsir S-1 carries 1257 E6 surface-to-air missiles per unit. Each missile costs roughly $5 million. The decoy drones were built for under $15,000 apiece. The exchange ratio was catastrophic for the defenders, and Russian doctrine demands engagement of all detected aerial contacts. Standing down and letting a target pass was not an authorized option. 4 Pantsir batteries engaged over the first 6 minutes. 22 interceptor missiles expended. 7 decoy drones destroyed. 11 primary strike drones, flying low and slow along the River Valley corridor, undetected and untouched. But here is where the first obstacle nearly collapsed the mission. At the critical corridor junction, the 18-kilometer gap in radar coverage, ground-based radio frequency interference flooded the frequency band the Ukrainian drones used for navigation updates, not Russian jamming. Commercial interference from a cellular tower installed along the river valley in the months since Ukrainian intelligence had last mapped the electromagnetic environment. 4 of the 11 strike drones lost navigation lock. 2 recovered autonomously after their onboard inertial navigation systems compensated. 2 did not. They began drifting off course, following their last known heading rather than the planned approach vector. The drone controllers, monitoring the package from a hardened operations center well inside Ukrainian territory, had seconds to decide. Abort the mission. Sacrifice the element of surprise, lose the carefully timed strike window when the refinery was at peak processing pressure, or continue with 9 confirmed strike assets and hope the geometry still worked. They continued. 9 drones threading a gap in Russian radar coverage on final approach to a target that had never been struck before, with a mission architecture that depended on hitting the primary column's Weld junction from a specific angle at a specific velocity. How many strike drones successfully penetrated to the target? A, 6, B, 8, C, 9. The answer comes at the end, and it changes how you assess this mission's outcome. The refinery's own radar, a short-range industrial security system installed after earlier Ukrainian drone campaigns had put Russian industrial facilities on alert, detected the incoming package at roughly 12 kilometers. The facility's security control room issued an alarm. Workers in the primary distillation unit began emergency shutdown procedures. Here is where the engineering calculation proved its worth. Emergency shutdown of an atmospheric distillation column doesn't happen instantly. The thermal mass of the system, hundreds of tons of steel, piping, and processed hydrocarbons at operating temperature, takes time to cool and depressurize. The emergency shutdown procedure itself creates a specific transient state where internal pressure briefly spikes before the relief valves can equalize. During the roughly 4 to 7 minutes of emergency shutdown initiation, the column is actually under higher stress than during normal operation. Ukrainian strike planners had calculated this. The alarm was part of the plan. By the time the first drone reached the outer perimeter of the refinery complex, the primary column was not winding down. It was in the highest stress state of its operating cycle. Subscribe to Ukraine Radar if you want to understand how modern warfare actually works, because this is the kind of planning that doesn't make headlines but determines the outcome of wars. The first 3 drones hit the perimeter infrastructure: pipeline manifolds on the western approach, a heat exchanger station, a secondary pump cluster. These were not the primary targets. They were force multipliers. Hitting the peripheral infrastructure triggered additional automatic safety responses from the refinery's control systems, further complicating the shutdown sequence and keeping the primary column pressurized for additional minutes. Then the 4th drone found the weld seam. The warhead had been modified for this specific impact profile. Standard anti-armor penetrators are designed to defeat armor steel. High hardness, thin profile. Refinery column steel is different, softer, thicker, designed to contain pressure rather than resist kinetic impact. Ukrainian weapons engineers had adjusted the penetrator geometry and warhead delay timer for this target. The drone hit the column at an angle 23 degrees off horizontal, penetrating the outer steel wall before the shaped charge detonated inside the column structure. The resulting pressure wave propagated through a column already at peak operational stress. The pre-existing microfractures at the Weld junction, documented in maintenance records obtained by Ukrainian intelligence, provided the path of least resistance. The column split, not a fire, not a burn, a split. The primary distillation column of the Ryazan refinery cracked longitudinally at the weld seam, releasing superheated hydrocarbon vapor under full operating pressure. The vapor cloud ignited within seconds. The resulting explosion was not a simple fuel fire. It was the detonation of pressurized industrial feedstock, equivalent to an industrial catastrophe of the kind that takes decades of negligence to produce. Ukrainian engineers had produced it in under 4 minutes of engagement. Satellite imagery captured in the hours after the strike showed the primary distillation unit structurally collapsed. The surrounding secondary infrastructure, heat exchangers, condensers, associated pipework, had been torn apart by the pressure wave. A secondary fire burned in the fuel storage section of the complex for an estimated 16 hours before Russian emergency services could establish containment perimeters. The central question this mission raises is one Russian defense planners are still working through. If open-source industrial safety documentation can be weaponized this precisely, how do you defend critical infrastructure that isn't classified? The answer, it turns out, is that you can't. Not with the tools Russia currently has available. Combat damage assessment, compiled from satellite imagery, cross-referenced with Ukrainian General Staff reporting and independent OSINT analysis, indicated the primary distillation unit was destroyed beyond repair within any operational timeframe. Reconstructing a primary column of that scale requires specialized manufacturing, specialized installation equipment, and timelines measured in months to years. The Ryazan facility's contribution to Russian fuel logistics for the southern grouping was effectively zero from the moment that Weld seam gave way. Russian sources tried to minimize the damage in the hours after the strike. Initial official statements described a fire at an industrial facility that had been localized by emergency services. That characterization lasted roughly 6 hours before satellite imagery from commercial providers made the actual scale of destruction publicly visible. The primary column was not on fire. It was gone. Intercepted communications from Russian Military Logistics Command, analyzed and referenced in Ukrainian military intelligence briefings, showed immediate concern about fuel allocation for aviation assets operating from southern bases. The Ryazan facility had been supplying jet fuel to a network of military airfields extending from the Moscow area south toward the theater of operations. With the primary distillation unit offline, that supply chain required immediate rerouting. A process that stressed alternative facilities and created the kind of logistical friction that compounds across an entire operational system. If you believe that industrial targeting is as decisive as battlefield maneuver, that destroying fuel infrastructure can shape the tactical picture as much as destroying tanks, type Ukraine radar in the comments. The debate between these two approaches to modern warfare is one of the most contested in contemporary military theory. The Russian air defense failure demanded a postmortem that, based on intercepted communications and subsequent changes in battery positioning observed by satellite, appears to have been conducted with considerable internal acrimony. The decoy strategy worked at a ratio that exceeded Ukrainian planners' expectations. Pantsir batteries had expended far more interceptors than doctrine-specified engagement protocols justified. The reason, analysts believe, is institutional. Russian air defense operators had been drilled for years on the threat of Western cruise missiles and ballistic warheads. The decision algorithms embedded in their training, and in some cases in their fire control software, treated every aerial contact as a potential high-value threat requiring immediate engagement. Faced with a coordinated swarm mixing decoys with strike assets, the system had no protocol for discrimination. It engaged everything it could, at maximum response, and still failed to stop the package that mattered. The second failure was intelligence. The Ryazan facility's security alert was supposed to generate a military response, scrambling interceptors, activating area air defense, alerting the Pantsir units that hadn't yet engaged. The response arrived. But it arrived after the primary strike drones were already inside the facility perimeter. Communication delays between the refinery security control room and the Regional Air Defense Coordination Center had been documented in Russian emergency response planning exercises and had never been corrected. Ukrainian intelligence, somehow, had obtained records of those exercises. The third failure, arguably the most damaging, was the maintenance deferral. The weld seam that failed under the strike had been flagged for inspection. The inspection had been scheduled. The scheduling had been overridden twice by production managers under pressure to maintain output volumes. Keeping the column running rather than taking it offline for maintenance had been a purely economic calculation. In an environment where the refinery was under no perceived threat, where nobody believed a Ukrainian drone could reach Ryazan, the maintenance deferral seemed rational. What would NATO logistics doctrine have done differently to protect this type of critical infrastructure? Comment your strategic analysis below. The maintenance records were the intelligence gift that shaped the entire mission architecture. Without them, strike planners would have targeted the column based on general engineering principles. A capable strike, probably damaging, but not necessarily catastrophic. With specific knowledge of where the metal had fatigued, they could guarantee the outcome. This is the doctrine shift the Ryazan strike represents, and it's one that military planners around the world are now incorporating into their targeting frameworks. The integration of open-source engineering intelligence. OSINT applied not to military positions, but to industrial infrastructure vulnerabilities, is a genuinely new dimension of long-range strike capability. It requires different skills than traditional military targeting. It requires engineers, not just analysts. It requires patience. Weeks of document review, not hours of satellite imagery interpretation. And it requires a willingness to think about warfare in terms that cross the boundary between military and industrial. Ukraine has developed that capability. The 14th UAV Regiment executed the kinetic component. But the mission was won in the weeks before launch, by analysts who understood that a maintenance deferral form was as strategically important as a satellite image of a Pantsir battery. The obstacle the mission faced, 4 drones losing navigation lock in the interference corridor, carries its own lesson. 2 of the 4 recovered autonomously. 2 did not. The 14th UAV Regiment's after-action analysis identified the commercial cellular interference source as a systematic intelligence gap. The electromagnetic environment along planned strike corridors hadn't been surveilled recently enough. That gap has since been corrected. Ukrainian drone strike doctrine now includes real-time electromagnetic environment mapping as a mandatory pre-mission checklist item with minimum acceptable survey windows defined in the strike planning protocol. The 9 drones that reached the target. The answer to the earlier question is 9, not 8, not 6. Achieved an outcome that required surgical precision to calculate and industrial knowledge to exploit. But the mission that mattered most was the incomplete one. The 4 navigation failures, the 2 that couldn't recover, forced the commander to make a real-time decision with incomplete information under time pressure. Continue or abort. 9 assets instead of 11. Geometry changed. Outcome uncertain. The decision to continue was correct, but it was not guaranteed to be correct at the moment it was made. And that human judgment, the regiment commander reading incomplete data and committing to a course of action with irreversible consequences, is the element of modern warfare that no drone, no algorithm, and no targeting software can replace. The lessons of the Ryazan strike run in multiple directions. For Ukraine, the mission validated a targeting methodology that will shape future deep strike operations. Industrial infrastructure is not an abstract strategic target. It's an engineering system with specific vulnerabilities. Vulnerabilities documented in public records, accessible to analysts with the patience and expertise to find them. The next strike of this type won't need to rediscover this methodology. It will refine it. For Russia, the strike exposed a critical gap in the integration between industrial security and military air defense. A refinery alarm that should have triggered an immediate military response instead generated a delayed notification that arrived after the engagement window had closed. That gap is now known. Whether it has been corrected across other strategic facilities, or whether the same integration failure exists at refineries, power generation facilities, and rail marshalling yards across Russia's industrial depth, is an open question that Russian defense planners are urgently trying to answer. For the broader study of modern warfare, the Ryazan operation offers a template for how asymmetric strike capability evolves when one side can't match the other in conventional depth. Ukraine can't strike Moscow with artillery. It can't threaten Russian logistics with tank columns. What it can do, what the 14th UAV Regiment demonstrated, is combine long-range drone technology with engineering intelligence to reach targets that nobody, including the targets themselves, believed were at risk. The quiz answer: 9 strike drones reached the Ryazan facility, not the 11 launched, not the 6 that Russian sources initially claimed were involved. 9. And 9 were enough, because the planning had built in sufficient redundancy that losing 2 platforms to navigation failure didn't collapse the mission. The 4th drone to reach the primary column, not the first, not the last, hit the weld seam at the calculated angle with the engineered warhead. The column split. The mission succeeded. Was the decision to continue with 9 drones instead of aborting the right call? The outcome validates the choice, but outcomes don't always validate decisions. In a parallel timeline where the navigation interference had taken 5 drones instead of 2, or where the column's weld fractures had been less advanced than the maintenance records suggested, the same decision produces a different result. The commander couldn't know which timeline he was in. Could Russia have prevented this strike? Not with the air defense architecture that existed at the time. The decoy saturation strategy was designed to exhaust Pantsir interceptor capacity before the strike drones reached their approach corridor. But correcting the industrial security integration gap, maintaining the primary column on schedule rather than deferring maintenance, and updating the electromagnetic survey of potential approach corridors. Any one of those administrative decisions might have changed the outcome. 3 separate failures had to align for the mission to succeed as planned. They did. That alignment was not luck. Ukrainian intelligence had identified all 3 failure modes before the first drone launched. What would you have done differently? As the regiment commander, as the refinery security director, or as the Russian air defense coordinator watching your Pantsir batteries drain their interceptor loads at decoys? The answer matters because these decisions, made under pressure with incomplete information, are the actual texture of modern warfare. Not the drones, not the warheads, the decisions. Real tactics, real consequences. Ukraine radar. The Ryazan refinery complex is offline. The primary distillation column is a compressed tangle of stressed steel and fire-blackened piping where superheated hydrocarbons once rose through separation stages at 400 degrees. The fuel that should have flowed south toward the front is not flowing. The aviation assets that depended on it are operating on reduced allocation. The logistics officers who built their planning around that supply chain are rebuilding from different assumptions. And somewhere in Ukraine, in a hardened operations center that will not be named and at an address that will not be confirmed, the 14th UAV Regiment is already planning the next mission. Will strikes like this one force Russia to pull air defense assets from the front to protect industrial infrastructure? Comment yes or no, because the answer determines whether Ukraine's deep strike strategy is already reshaping the air defense balance over the battlefield. Subscribe to Ukraine Radar, because we break down the battles that textbooks will study for decades. The Ryazan skyline is quieter now than it was before, but the gap where the primary column stood is visible in every commercial satellite pass, a silent proof of concept. A demonstration that modern warfare punishes not just tactical mistakes on the battlefield, but administrative decisions made in boardrooms and maintenance scheduling systems by people who never imagined they were making decisions with military consequences. Stay vigilant.